In this example, we look at our leading term, so the second derivative of y. We don't have anything in front of it that would make it something we have to solve for, so we know that x equals 0 is an ordinary point. So the cosine x then would be considered analytic at that point. So we can then connect in what we've learned in the past. So if we refer back to the Maclaurin series for cosine and the fact that this thing is centered around 0, we know that the general pattern for our solution is going to look like this. So specifically, we can replace, let's see, so, well, not yet, hold on. We're going to replace in a second. So we know how to convert second derivative into power series. So n minus 1, c sub n of x to the n minus 2. And then the Maclaurin conversion of cosine into a power series is going to look like this. So it's going to have that pattern of 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot. And then it's going to be starting at 0 to infinity c sub n of x to the nth. So rather than try to get the indices to match and see if we can combine it into a singular summation, let's just try to expand everything out. Because at this point we've seen that we're going to have this infinite pattern. We're going to try to look for patterns within patterns of the infinite expansion. So let's focus on this guy for just a second and just talk about, well, what would it look like if I expanded out? So we know if I plug a 2 in there, I get 2c2. Okay, but what happens if I keep going? So if I put a 3 in there, I get 3 times 3 minus 1, so that's 6 c3 to the x. And then if I evaluate it at a 4, I get 4 times 3. Okay, so that should be 12 c4 x squared plus, and if I go one more, that's 20 c to the 5 x cubed. You know, and so in general, you just kind of keep expanding until you see a relevant pattern. So maybe you got to do this several times before something jumps out at you like, oh, okay, that's interesting. And then with the other Maclaurin series, so let's talk about this guy. All right, so not much we can do with the factorial, so that's just, so I'm going to carry that over, so 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. All right, so that's all in there. But when I expand out the other one, that's just c0 plus c1x plus c2x squared plus dot dot dot. Okay, so then let's have a conversation about, well, what do we notice is relevant with corresponding exponents? So, for example, what would generate the constant versus x squared? So if I just start partnering them up, again, keep in mind, this is an infinite series here. Oh, goodness. I just caught that way early on. I wrote c sub 3, and it should be c sub 2. Whoops. Okay, so without any variables, I should have a 2 c sub 2 plus a c sub 0 and then if I put x's in there, I got 6c3 plus c1x plus, at least go, yeah, well, let's see, this would be 12, so I'm looking at the squared terms, so 12c4 plus c2 and then minus 1/2 c0, so that's all in terms of x squared, plus dot dot dot, and that's all equal to 0. Which then brings up another conversation about each of those patterns. So in order for that to be 0, that means individual sets of terms, individual combinations. So this combination has to be 0. This combination has to be 0. This combination has to be 0. So let me write that out. So 2c2 plus c0 has to be 0. And 6c3 plus c1 has to be 0. And 12c4 plus c2 minus 1/2 c0 has to be 0. And so we can generate a whole infinite series of these equations, but what we'll notice when we start solving for individual ones is that c2 equals negative 1/2 c0, c3 equals negative 1/6 c1, and since I have an expression for c2, I can use that in the c4 equation, and so I can just figure out that c4 is 1/12 c0, and I can keep going. So maybe I got to do this a couple more times to get general solutions here. And then in general, our solutions are going to look like, again, a function of c0 y1 of x plus c1 y2 of x, and I can essentially start grouping these things together. So y1 would be anywhere in my initial pattern where I see the c0, sorry, c1, c0. So if I just go in and collect up each of those individual terms in my general expansion, I'd get something like y minus 1/2 x squared plus 1/12 x to the 4th dot dot dot, and I'd get y2 of x, and this is going back and collecting up all of my c1 patterns. Would look something like x minus 1/6 over x cubed plus, and this one I don't even have on the screen. I'm just going to give it to you. It's 1 over 30 x to the 5th, right? Dot dot dot. Right. So this is where you got to go off direction. So if the assignment, if the problem asks you to identify the first 3 terms in the pattern, then you just have to go back in and keep expanding things out until you can finally see how big a pattern you need.